Hi, welcome to my channel pibyme Maths. In this video, we are going to be looking at October 2023 Statistics 1 paper. Let's look at question number 1. Sally plays a game in which she can either win or lose. A turn consists of up to 3 games. On each turn, Sally plays the game up to 3 times. If she wins the first 2 games or loses the first 2 games, then she will not play the third game. Okay, the probability that Sally wins the first game is this: wins a game. If Sally wins a game, the probability that she wins the next game is this. If she loses a game, the probability that she wins the next game is 0.2. We need to complete this tree diagram. Okay, if this is 0.7, this is no-brainer, 1 minus 0.7, because the total should always be 1. So if this is 0.6, this is 0.4. Okay, now if she loses a game, the probability she wins the next game is 0.2. So if she loses a game, the probability that she wins the next game is 0.2. If she loses a game, the probability that she wins the next game is 0.2. This is 0.2, this is 0.8. And then, if she wins a game, the probability that she wins the next game is 0.6. So if she wins a game, the probability that she wins the next game is 0.6. That's why they put 0.6 here also. And 0.4 here, 1 minus 0.6. That's how we complete this tree diagram. Part B. Now find the probability that Sally wins first 2 games in a turn. Okay, probability of first to win. She wins the first 2 games. So this times this, first 2 games. So you need to multiply these two. 0.7 times 0.6, 76 or 36, 42, 0.42 is the answer for part B. Part C now. Find the probability that Sally wins exactly 2 games. First 2 is different from exactly 2 win. So when we say exactly 2 win, it can be first 2 win, that's the probability of this, plus it can be first loss, second win, third win, or first win, second loss, third win, right? So we need to get the probability of this. So 0.42 plus loss, win, win. So we need to take loss, win, win, multiply this 3.3, 0.2, 0.6. 0.3 times 0.2 times 0.6 plus win, loss, win. Win, loss, win. 0.4, 0.7, 0.4, 0.2. 0.7, 0.4, 0.2, get this probability. That's the answer. So 0.42 plus 0.3 times 0.2 times 0.6 plus 0.7 times 0.4 times 0.2. 0.512 is the answer. Part D now. It's a conditional probability. Given that Sally wins 2 games in a turn, find the probability that she won the first 2 games. They want you to find the probability of first to win given that 2 win. Exactly 2 win is the probability we just calculated. So it's an intersection of these two. First to win, intersection exactly 2 win, divided by probability of exactly 2 win. Exactly 2 win is what we calculated in part C, 512. Intersection of these two is same as first 2 win, right? So take the answer of first win, which is 0. That's the answer from part B, 0.42. So you divide, you will get the answer. So 0.42 divided by 0.512, 0.8203, etc. You can round it to 3 significant figure, 820. Part E now. Given that Sally won the first game in a term, she won the first game. Okay, that's a condition. First win, that's a condition. Find the probability that she won 2 games. P of 2 win. So that's a conditional probability. So you need to find the intersection of 2 win and first win divided by P of first win. P of first win is apparently 0.7, right? So the denominator is going to be 0.7, and then 2 win intersection of first win. So you need to take the probability of 2 win, where the first one should be win actually. So that's this times this plus this times this times this. So in both cases you have 2 win and the first one also win. So it's basically 0.7 times 0.6, 0.7 times 0.6 plus 0.7 times 0.4 times 0.2. 0.2, right? Yes. So basically 0.7 times 0.6 is 0.42 plus 0.7 times 0.4 times 0.2 divided by 0.7. 0.68 is the answer. Just a 2 more question. Question number 2 now. The weights to the nearest kilogram of a sample of 33 red kangaroos taken in December are summarized in stem and leaf diagram below. Okay. Always take note of the key of the stem and leaf diagram. So if you see 3 bar and number, that's considered 32 kilogram. Okay. Let's read further. Part A, find the value of median, the value of Q1 and Q3 for the weights of these red kangaroos. Okay, to find this, you need to know how many entries are here, the total of this, which is what given here, 33. Even you sum up everything, you will get 33. So to find part AI median, which is Q2, you take 33 divide by 2, you will get 16 is 32, 16.5. So if you get a decimal number, you take the next entry, 17th entry. That would be the median Q2. 17th entry 1 plus 2 3, 3 plus 3 6, 6 plus 7 13, 14, 15, 16, 17th entry 57. So Q2 is 57. Double I. To find the lower quartile Q1, you divide 33 by 4. 33 over 4 is 8.25. So if you get a decimal number, you take the next entry, 9th entry. That will be Q1. So 9th entry, 1 plus 2, 3, 3 plus 3, 6, 7, 8, 9th entry, 45 is the lower quartile. Q1 is 45 kilogram, or just write 45. To find the upper quartile Q3, you need to find the 3/4 of 33, because that's a 75th percentile, right? So it's basically times this by 3. 24.75. So you need to take 25th entry. Whenever you get a decimal number, you take the next entry. What if you don't get a decimal number, you get a whole number 24? Then you need to take the particular entry, 24th entry plus next entry divided by 2. So remember this method. So I'm gonna take the 25th entry now. 1 plus 2, 3, 3 plus 3, 6, 6 plus 7, 13, 13 plus 8 is 21, 22, 23, 24, 25. We need 25th entry, which is 63. Let's look at part B now. For this data, an outlier is defined as a value that is greater than this or smaller than this. Okay, we need to find the range. Q1 minus, Q1 is 45 minus 1.5 times Q3 minus Q1. 63 minus 45. And then Q3 plus 1.5 times Q3 minus Q1. Let's calculate this. 45 minus 1.5 times 63 minus 45. It's going to be 18 if I'm not wrong. 18. So you get 18 here, and then find this value. 63 plus 63 Q3 plus this, you'll get 90. So that's the range to find the outlier. If any number lies outside the range, that means smaller than 18 or bigger than 90, that's considered an outlier. So they want us to prove there are two outliers. So let's look at the stem and leaf diagram. 16 is smaller than 18, right? So that's one of the outlier. And then 94 is bigger than 90. So you can write 16 is smaller than 18 and 94 is bigger than 90. Therefore 16 and 94 are outliers. That's all. Let's look at part C now. Figure 1 on page 7. This is the figure 1. Shows a box plot for the weights of 33 red kangaroos taken in February. This is the box and whisker plot for February. They want us to draw a box plot for the weights of these red kangaroos in December. They want us to draw this actually. For the December one, we have the stem and leaf diagram here, right? For the December. So from here, we know 16 and 94 are outliers. So the next lowest number is 23. Highest number is this 86. And we have Q1, Q2, Q3 here. We need all these things: Q1, Q2, Q3, lower quartile, median, upper quartile, and lowest value, highest value, and outliers to draw the box and whisker plot. Okay, so the lowest value is 23. 20 is here. From 20, the third line, 1, 2, 3. And then if you want, you can just put it all the way up here. This 23 lowest value. And the highest value is 86. So 86 is 80 here. This is 86. This is 86. And then Q1, Q2, Q3. 45, 57, 63. 45 is here. 57 is in here. And then 63, 61, 2, 3, 63. Join this Q1, Q2, Q3 and draw a box, and draw the two whiskers connecting lowest value and the highest value. And then the outliers are 16 and 94. So 16 is here. So you put a little cross mark here, and then 96, 95, 96, you put a cross mark here. That's how you draw the box and whisker plot. So you need to mention everything clearly, like outliers and everything. So I'll be given 4 marks. Let's look at part D now. Compare the distribution of the weights of red kangaroos taken in February with the distribution of the weights of red kangaroos taken in December of the same year. So we have 2 box and whisker plot here. We need to compare them. You should interpret your comparisons in the context of the question. Okay, I'm going to tell you how to do this. Look at this diagram. Look at the median in February. It's almost equal to 50, right? Here we have 57. So first you need to write using the median. You need to write median weight in December, which is 57 kilogram, is more than the higher than the median weight in February, which is almost equal to approximately equal to 50 kilogram. So the kangaroos are generally heavier in December. That's one point. And then let's look at the IQR, interquartile range of December. We know Q1 and Q3, right? Q1 and Q3 are 63 and 45. So here 63 minus 45, you get 18. That's the interquartile range. Here this value is almost like 51 to 55, 6, 7, 8. 58 is Q3. 42 is Q1, so you'll get 16. The IQR of this one is higher than the February, right? So you need to write when the IQR is the interquartile range is bigger, that means it has a higher spread, actually larger spread. So you need to write December has slightly larger spread, so the weights are more varying here compared to February. That's one of the point. And then not interquartile range, look at range now. The lowest value almost like 28, and then the highest value is 80. 80 minus 28 is almost like 52. Here we know the lowest value, which is 23 and 86. So 86 minus 23, we got 63. Even you include the outliers, it becomes much larger actually, because 96 minus 94, right? Okay, in the diagram also I should have put 94 here, not 96. So 94 minus 16, that's 78. So it has a larger range, right? So you need to write December has much larger range. That means more extreme weights actually. So to conclude, I will tell you what are the points you should write here. You should write the median in height in December. The median weight in December is higher than the weight in February. So the kangaroos tend to be heavier in December. That's one point. The spread is also greater in December, both IQR and the range. So both IQR and the range are heavy or larger in December. That indicates more variation in weights in December. So overall, the kangaroos are heavier and their weights are more spread out in December compared to February. That's how you write. You need to make your own sentence and write. Let's look at question number 3 now. Bob shops at a market each week. The event that Bob buys carrot is denoted by C. He buys onions is denoted by O. At each visit, he buys neither or one or both of these items. He buys carrots at 0.65, does not buy onions, buys onion but not carrots. And we have a Venn diagram given here. Find the value of W, X, Y, Z. This is for onion, this is for carrot. Now let's read the question carefully again one more time. This is P of C is 0.65. Does not buy onion is P of O complement is 0.3. Buys onions but not carrots. That's this part actually, this one, right? 0.15 is this part. So you can straight away write W is equal to 0.15. You don't need to show any working. We know P of O complement. So P of O is 1 minus P of O complement. We know P of O complement is 0.3. So this is going to be 1 minus 0.3 is 0.7. That means this whole circle is 0.7, but we already have 0.15. So you can write X is equal to 0.7 minus 0.15 is 0.55. This is 0.5. We know P of C. P of C is given as 0.65. That means this whole circle is 0.65. We already have 0.55 there. So Y will be 0.65 minus 0.55 is 0.1. And the total probability should be 1. So Z is 1 minus 0.15 minus 0.55 minus 0.1. Which is 0.65, 75.8, Z is 0.2. That's all. It's a 4-mark question. Let's look at part B. For one visit to the market, find the probability that he buys either carrots or onions, but not both. Okay. You see, when you have a Venn diagram, let's say this is C and D. That's C and O and C. O and C. That's the Venn diagram we have here, right? Okay. When they say either carrot or an onion, but not both. Not both means you need to neglect the middle part. You need to take only this and this. If it says either carrot or onion or both, you need to take all three actually. It's like O union C actually. But here you need to leave the middle part. So you need to take the numbers from these two parts actually. 0.15 plus 0.1. 0.15 plus 0.1 is 0.25 is the answer. Now show that C and O are not independent. Let's find C intersection O, which is the middle part, which is given here as X, 0.55, right? Now let's find P of C times P of O, because that's a formula for independent events. If these two are same, these two events are independent events. So P of C is 0.75, right? P of C is 0.65 times P of O. We calculated P of O here, 0.7. So 0.65 times 0.7, you get 0.455. P of C intersection O is not equal to P of C times P of O. So I need to write the conclusion. Therefore, C and O are not independent. Or not independent. Let's look at double I now. Double I is entirely a different question actually. F, G, H are three events. F and H are mutually exclusive. Okay. F and G are independent. Find F union H. Since they are mutually exclusive, the formula for mutually exclusive is P of A union B is P of A plus P of B. So 2 over 7 plus 1 over 4. 2 over 7 plus 1 over 4. 15 over 28. Part B. Find P of G. Okay. We know F and G are independent, right? So I'm going to use the rule for independent events. P of F intersection G is equal to P of F times P of G. That's the formula for independent events, right? And I'm going to use the probability addition formula here. P of A intersection B can be written as P of A plus P of B minus P of A union B. That's a probability addition formula. It's given in the data booklet. It's P of F times P of G. Now I'm gonna sub in all the known quantities here. 2 over 7 plus P of G minus F union G is 5 over 8 is equal to 2 over 7 times P of G. Make P of G as a subject. So I'm gonna simplify these two and push it to this side. Push this one here. So I will get 1 minus 2 over 7 times P of G. If I take P of G as a common factor, 5 over 8 minus 2 over 7. 5 over 8 minus 2 over 7. 19 over 16. So P of G will be, you divide the answer by this, which is 5 over 7. Divided by 5 over 7. 19 over 40 is the answer. So now part C, find P of F intersection G. We know F and G are independent, so sub in this formula. 2 over 7 times 19 over 40. So when you simplify, you'll get 140. 19 over 140 is the answer.